Assalamu alaikum. Well, children, in the previous video we solved questions of the exercise 8.2. We solved 3 questions of that exercise, and one question was left that day, question number 4. We'll begin with this question today. We have to state, some statements are given here. We have to say whether these are true or false, and you have to justify your answers. We'll begin with this, and then we'll begin the next topic, which is a very important topic. The first part here is question 4, part 1, sine of A plus B. According to the given statement is equal to sine of A plus sine of B. We have to say whether this statement is true or false. Recollect, we have earlier come across in algebraic expressions, if you have 2x into 3y plus 4, we read this as 2x multiplied by 3y plus 4. This is algebra. This is trigonometry. You were earlier told when we write sine A, it does not mean sine is multiplied by A. It is an abbreviation. Sine of the angle A. Likewise, here we have this A plus B in the bracket, this A plus B, A and B together make the angle here. Therefore, sine of A plus B does not therefore mean the product of sine and A plus B. It does not mean. It is abbreviation again for sine of sum of 2 angles A and B. Had it been the product, then algebraic law would apply. Distributive law would be applied. 2x would multiply 3y, 2x would multiply 4 also. That would have been had it been the multiplication. But this being trigonometry, this is not the product, it is the abbreviation. Therefore, that distributive law which we apply in case of multiplication cannot be applied here. And when we look at the result here, we find the result obtained is by distributive law, as if it is multiply here. Sine of A plus sine of B. Distribution has taken place. Now, since this is not the product, therefore distributive law cannot be applied. As such, this statement is false. Sine of A plus B is not therefore equal to sine A plus sine B. And the reason is now clear. You will write there, this statement is false. You can write on your copies, this statement is false because sine of A plus B is not the product of sine and A plus B. Therefore, distributive law cannot be applied. That was question part 1 of this question. Now second part. Second part is the value of sine theta increases as theta increases. The value of sine theta. It is about sine theta. To answer this question, you have to look at the values of sine theta from the table. When theta is values of theta 0 degree, 30 degree, 45 degree, 60 degree, 90 degrees. We have seen the value of sine there is 0, then 1 by 2, 1 by under root 2, under root 3 by 2, and finally 1. Statement says the value of sine theta increases. These are in increasing order. These values which are given in front of sine, statement says these are in increasing order. As theta increases, sine also increases. we find theta is in increasing order, 0, then 30, 45, 60, 90. This is in increasing order. Statement says with the increase in the value of theta, sine theta also will increase. Means these values of sine also will be in increasing order. You have to say whether it is true or false. To understand this, we will express all these in decimal form. 1 by 2 in decimal form becomes 0.5. You have to divide 1 by 2 with 0.5. Similarly, 1 by root 2 in decimal form becomes 0.7. 7 something, 0.7 something is there. One digit I shall use 0.7. Then root 3 by 2 is 0.8. 1 is already in decimal form. The values of sine theta therefore are 0, 0.5, 0.7, 0.8, 1, and you can see these are in increasing order. 0 is the smallest, 0.5 is larger than that, 0.7 is larger than that, 0.8 is larger than that, and 1 is the largest among these. Therefore, as theta increases, sine theta also increases. The statement is true. Now you will write the statement is true, and the reason will be this. You will write values of theta in increasing order, values of sine theta you will write, and then show those are also in increasing order. This was second part. Then comes part number 3. It is the question, a similar question now about cos. The value of cos theta increases as theta increases. We again have values of theta, same, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Increasing order of angles. Now this time, instead of their sine values, you have to write their cos values. And we have seen cos theta is 1. Cos 30 is under root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is 1 by 2. Cos 90 is 0. Now, are these in decreasing order or increasing order? As theta increases, we find cos theta decreases. Because the decimal forms are already given to you. This is 0.8. This is 0.7. This is 0.5. The values go on decreasing as theta increases. Values of cos theta go on decreasing. But the statement says cos theta increases. Here they are shown in decreasing order. Therefore, this statement is false. Part 4. Part 4 is sine theta is equal to cos theta. Values of sine theta and cos theta are equal according to the statement for all values of theta. This is the next statement. This is the short form for all values of sine theta is equal to cos theta for all values of theta. Now you have to say, is this true or false? Well, again, recollecting the table, let us choose theta is 30 degrees. When theta is 30, sine theta will become sine 30. Cos theta will become cos 30. And what do you find? Are those equal? Sine theta we know is 1 by 2. Sine 30 we know is 1 by 2. Cos 30 we know is under root 3 by 2. Those are not equal. Similarly, if you choose theta equal to 45, we find sine theta will become sine 45 and the value is 1 by root 2. Cos theta will become cos 45. Again the value is 1 by root 2. The two are equal here. 1 by root 2, 1 by root 2. For theta equal to 45 degrees. And if we choose theta equal to 60 degrees, sine theta will become sine 60, which is under root 3 by 2. Cos theta will become cos 60, which is 1 by 2. Again they are not equal. Thus, what do we find? Sine theta is not always equal to cos theta. The statement that sine theta is equal to cos theta for all values of theta is therefore false. The statement is true for only theta equal to 45 degrees. That was part number 4. And the last one, the fifth one is cot A, your angle is A, cot A is not defined for A equal to 0, is not defined for A equal to 0 degrees. You have to say whether this is true or false. The value of A is given to you. You have to use 0 as A. Thus cot A will become cot 0 degrees. So what will you do in order to answer this question? From the table find cot 0. It is not defined there. But the statement here says is not defined. Same, is not defined. There also we get it is not defined. This statement is therefore true. Cot A is not defined for A equal to 0 is true. Because cot 0 is equal to 1 by 0. Cot A, cot 0 here, because A is 0, is equal to 1 by 0. And whenever denominator is 0, the result is not defined. That completes this exercise. This was the question left from the previous exercise. Now we shall begin another exercise, and it is about trigonometric ratios of complementary angles, a very important topic. Carefully try to understand trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. Now, before we discuss trigonometric ratios of complementary angles, let us see what we mean by complementary angles. You have read earlier, angles which have sum equal to 90 degrees. Angles having sum equal to 90 degrees are called complementary angles. Now, when we consider a right triangle, because we have defined trigonometric ratios in terms of right triangle only. So therefore, this topic also will be about right triangle. If we name the triangle as ABC and right angled at B, then its acute angles are A and C. Since the sum of all the three angles of the triangle is 180, and out of that angle B alone is 90, then angle A plus angle C will be equal to 90 degrees. Angle A plus angle C is 90. Two acute angles of a right triangle therefore are complementary angles because their sum is equal to 90 degrees. This topic is about complementary angles. These angles, acute angles of the right triangle. Two acute angles of a right triangle are complementary angles. So what will we do in this topic? We will find trigonometric ratios of both angle C as well as angle A, which are complementary, and then relate those with each other. We can from this get angle C is equal to 90 minus angle A. By transposing angle A to the other side, we got that minus sign. So we have angle C equal to 90 minus angle A. Even instead of transposing A, if you transpose C, you will get angle A equal to 90 minus angle C, a similar result. We will use in our discussion angle C equal to 90 minus angle A. So remember, the acute angles of a right triangle are complementary angles. Their sum is equal to 90 degrees. So in this topic about trigonometric ratios of complementary angles, what will we do? We'll find trigonometric ratios of both these complementary angles. We'll find trigonometric ratios of angle C by using definition. We'll find trigonometric ratios of angle A by using definition done in the first exercise, and then we'll relate those with each other. The relations thus got will be called trigonometric ratios of complementary angles. So let us consider first angle C. We'll first find trigonometric ratios of angle C. With respect to angle C, we'll call BC as base and AB as perpendicular. This AC is the hypotenuse. What will be then sine angle C? Sine C. Definition says sine is perpendicular by hypotenuse. This is the definition of sine. Now, with respect to angle C, we have already understood, we have already identified the perpendicular, it is AB, thus it is AB by AC. Sine C is AB by AC. What will be cos C? By definition, it is base by hypotenuse. And therefore, it will be, with respect to angle C, what is base? Base is BC, so it is BC by AC. Tan C, tan is perpendicular by base by definition, and therefore it is AB by BC. The remaining three are reciprocals. Cot C is reciprocal of tan. It will be BC by AB, therefore. Sec C is the reciprocal of cos. Cos is BC by AC. Sec C will be then AC by BC. And finally cosec. Cosec C will be reciprocal of sine C. Sine is perpendicular by hypotenuse, it is AB by AC, and the reciprocal then is AC by AB, that will be cosec. These are trigonometric ratios of C angle. We will also find trigonometric ratios of angle A. Angle A is the complementary angle of angle C. So find trigonometric ratios of angle A. Let us begin with sine A. Definition is same, perpendicular by hypotenuse. But this time, since the acute angle has changed, therefore we'll have base and perpendicular also redefined. With respect to angle A, our perpendicular will become base and our base will become perpendicular. AB will now be the base. BC will become perpendicular. Therefore, sine A now will be BC by AC. Cos A, definition is base by hypotenuse, and it will therefore become AB by AC. Tan A is perpendicular by base by definition, and therefore it becomes BC by AB. Again, the remaining three reciprocals. Cot A is reciprocal of tan. It will be therefore AB by BC. Sec A, reciprocal of cos. It will be AC by AB. And cosec A, reciprocal of sine, will be AC by BC. In order to find trigonometric ratios of complementary angles, what did we therefore do? We first identified which are the complementary angles in the right triangle. A and C are the complementary angles. We then found trigonometric ratios of angle C separately. These are the trigonometric ratios of angle C. We also found trigonometric ratios of angle A. These are the ones. Trigonometric ratios of angle A. Then these will be compared with each other to get the relations which we'll call as trigonometric ratios of complementary angles. So far we have trigonometric ratios of acute angles. C separately, A separately, we have found those. Now when we rate these with each other, compare these with each other, new relations that we'll get, those will be called as trigonometric ratios of complementary angles. Now find out by comparison. We have AB by AC here, sin C. AB by AC is in this list also. This is AB by AC here, cos A. Therefore, by Euclid's axiom, we'll get sin C is equal to cos A. This is first relationship between complementary angles. Here, angles involved are complementary angles. A and C, those are complementary angles. Sin C is equal to cos A. Likewise, second ratio here is BC by AC. And this again is in the second list also. BC by AC is here. Here it is sin A, here it is cos C. So we'll get cos C is equal to sin A. The second relation. And as you go on comparing, you will find tan C is equal to cot A. Cot C is equal to tan A. Sec C is equal to cosec A, and cosec C is equal to sec A. 6 relations we got therefore. These relations obtained are called trigonometric ratios of complementary angles. Now these relations are generally expressed by putting in the value of C we have earlier got. You were told A plus C is 90, angle A plus angle C is 90. From there we got angle C by transposing angle A. Angle C we got 90 minus angle A. This relation will replace C angle everywhere by 90 minus angle A. The relations will therefore become sin 90 minus A, angle A, is equal to cos of A. Then cos of 90 minus angle A is equal to sin of angle A. Tan of 90 minus angle A is equal to cot of angle A. Cot of 90 minus angle A is equal to tan of angle A. Sec of 90 minus angle A is equal to cosec of angle A. And the last one, cosec of 90 minus angle A is equal to sec of angle A. These 6 relations will be now used here onwards. Complementary angles, trigonometric ratios of complementary angles. And more conveniently, if we replace angle A by theta, if we put this angle A as theta, then this will become sin 90 minus theta is equal to cos theta. Sin 90 minus theta is equal to cos theta. Cos 90 minus theta is equal to sin theta. Tan 90 minus theta is equal to cot theta. Cot 90 minus theta is equal to tan theta. Sec 90 minus theta is equal to cosec theta. And cosec 90 minus theta equal to sec theta. What is that theta? It is an acute angle. It can have any measure, 10 degree, 20 degree, 30 degree, 40 degree. Any measurement it can have. Previously we had trigonometric ratios of specific angles. We have only 30 degree, 45 degree, 60 degree, derived their values. Now you can use here any acute angle, 1 degree, 2 degree, 3 degree, whatever you would like, other than those specific angles. And then correspondingly 6 relations we have. Sin is expressed in terms of cos, cos is expressed in terms of sin, tan is expressed in terms of cot, cot is expressed in terms of tan, sec is expressed in terms of cosec, cosec is expressed in terms of sec. These are complementary relations. Earlier you have seen reciprocal relations also. Sine is reciprocal of cosec. Cos is reciprocal of sec. Tan is reciprocal of cot. Now here we have complementary relations. Sine is complement of cos, not of cosec. Sine and cosec are reciprocals. Sine and cos are complementary. And it is here from the word complementary that this CO prefix is added to sine to form cosine. Cosine is CO of this complementary, and then word sine together they form cosine. Means complementary of sine. Likewise, tan and cot. Tan and cot are reciprocals also. Remember, they are complementary also. And now sec and cosec. Sec, then cosec. Again that prefix co is used here. Sec, co is added to it, it becomes cosec. Tan, co is added to it, it becomes cot. Actually it is tangent and this is cotangent. Tangent with prefix co makes it cotangent. Sec, secant is actually secant. Secant with the prefix co makes it cosecant. These are complementary relations. I shall conclude here. I shall conclude here to give you time to go through these relations again, so that in the next lecture when we do exercises, you will be having the things clear to you. In case any doubt is there about these relations, you can ask me on WhatsApp, so that before we begin the before I give you, send you the next video in which exercise will be solved, your doubts will be cleared. So all the best.